Welcome to our online chemistry class. Myself, Mukesh KHARGE from SSPMS and Junior College, Shivajinagar, Pune 5. Our topic is electrochemistry. Let us discuss part number 7. Our subunit is problems asked in board exam. These are some formulas you must know while solving the numerical based on this topic. Okay, so we'll revise again when we discuss specific numerical. Okay, so let us discuss the numerical based on this topic. Remember all these formulas. So first numerical is conductivity of a solution is 6.23 into 10 raised to minus 5 ohm inverse centimeter inverse, and its resistance is 13,710 ohm. If the electrodes are 0.7 centimeter apart, calculate the cross-sectional area of the electrode. So this numerical is asked in February 2016 for 2 marks. So what is the given thing? You must know that, and then you can solve the numericals. So conductivity, it is denoted by kappa, K, 6.23 into 10 raised to minus 5 ohm inverse, or it is also called as Siemens centimeter inverse. Then resistance is given 13,710 ohm. The electrodes are 0.7 centimeter apart, means length is given between two electrodes, and you have to calculate the area of cross section. So you must familiar with the relation between conductivity, resistance, and the length and area. So conductivity is equal to 1 upon R L by A. So you have to calculate A. So rearrange the formula. What we get? 1 upon R into 1 upon K or kappa. So substituting the values, A is equal to 1 upon 13,710 into 1 upon 6.23 into 10 raised to minus 5 ohm inverse centimeter inverse, and resistance in ohm. So ohm and ohm inverse get cancelled. So your unit is centimeter inverse at denominator, and here L is 0.7 centimeter. So we will solve this. Your answer is 0.8195 centimeter divided by centimeter inverse, so that is centimeter square. So the cross sectional area of the electrode is 0.8195 centimeter square. Now let us see the next numerical. Resistance and conductivity of a cell containing 0.01 molar KCl solution at 298 Kelvin are 1500 ohm and 1.46 into 10 raised to minus 4 Siemens centimeter inverse respectively. What is the cell constant? It is similar to the previous numerical. So resistance is given 1500 ohm and conductivity is 1.46 into 10 raised to minus 4 Siemens centimeter inverse. Okay, and you have to calculate cell constant, that is equal to B, or which is equal to L by A. So conductivity is K is equal to 1 upon R into L by A, that is nothing but B. So cell constant L by A is equal to conductivity into resistance. So 1.46 into 10 raised to minus 4 into 1500. So unit for conductivity is Siemens centimeter inverse, and that of resistance is ohm. So ohm and Siemens means ohm inverse, they get cancelled. So your unit is centimeter inverse. So what is the answer? 0.219 centimeter inverse. That is the cell constant. Okay, B is equal to L by A. Next numerical is resistance of conductivity cell filled with 0.1 molar KCl solution is 100 ohm if the resistance of the same cell when filled with 0.02 molar KCl solution is 520 ohms. Calculate the conductivity and molar conductivity of 0.02 molar KCl solution. What is the given thing? Conductivity of 0.1 molar KCl solution is 1.29 Siemens meter inverse. This numerical is asked in October 15 for 3 months. So first concentrate on the given things. Don't think that it is very difficult. So resistance of the conductivity cell with 0.1 molar concentration of that KCl is, let us suppose it is denoted by R1 100 ohm, and another solution 0.02 molar KCl solution whose resistance is R2 which is equal to 520 ohm. Then you have to calculate conductivity and molar conductivity of that second solution, that means K2 and lambda 2 if conductivity K1 of first solution is equal to 1.29 Siemens meter inverse. Okay, so this is the given things. So what is the formula? So conductivity and resistance of first solution is given. So with the help of that we can calculate the cell constant. So what is the formula? Cell constant is nothing but K1 into R1, conductivity of first solution into resistance of that first solution. So what is conductivity of first solution? It is 1.29 Siemens meter inverse, and the resistance of first solution is 100. So your answer is 129 meter inverse. Okay, then you can calculate conductivity of 0.02 molar solution by using same formula. So K2 is equal to B divided by R2, that is cell constant divided by resistance of that second solution. So cell constant is 1.29 centimeter inverse and resistance of that second solution is 520 ohm. So it is your answer 0.00248 ohm inverse, that is Siemens into centimeter inverse. Then you can calculate the molar conductivity of that second solution, capital lambda m is equal to 1000 K2 divided by C2. So 0.00248 into 1000 divided by C2 is 0.02. If we solve this, it is 124 Siemens centimeter square mole inverse. Okay. So here your conductivity is Siemens centimeter inverse. Concentration is molar, means moles per dm cube, and 1 dm cube is equal to 1000 centimeter cube. So that's why you have to multiply here by 1000. Then your concentration is mole per centimeter cube. So 0.02 centimeter mole per centimeter cube. Okay, so your answer is this one. Thousand centimeter cube per dm cube. Okay, and this is 0.02 mole per dm cube. So dm cube get cancelled. Your answer is 124 cement centimeter square per mole. Okay, so remember this, your molarity is in moles per dm cube or mole per liter, but here you have to use centimeter unit, that's why you have to multiply by 1000. The next numerical is, how many Faradays of electricity are required to produce 13 gram of aluminium from aluminium chloride solution? Okay, so given thing is molar mass of aluminium, which is equal to 27 gram per mole. In this numerical is asked for 3 mass in March 18. So first you must familiar with the reaction. Remember that aluminium is 13 group element and it donate 3 electron, or Al3 plus is the charge on aluminium. So Al3 plus gain 3 electron to produce Al. So this is the reduction reaction. So to produce 1 mole of aluminium, it requires 3 moles of electron. So 1 mole of aluminium corresponds to its molar mass, which is equal to 27 gram per mole. Okay. So 27 gram of aluminium correspond to 3 mole of electrons. So 1 mole of electron is nothing but 1 Faraday. Okay, but your mass is given as 13 gram. So 13 gram of aluminium require how much number of moles? So simple cross multiplication, 13 into 3 divided by 27. So your answer is 1.444 mole electron, and 1 mole electron correspond to 1 Faraday. So 1.444 mole electron correspond to how many Faraday? So simple cross multiplication, 1.444 into 1 divided by 1. So answer is 1.444 Faraday. That is the number of Faraday required. The next numerical is, how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten CaCl2 and 40 gram of aluminium from molten Al2O3. Given mass, molar mass of calcium and aluminium is given 40 gram per mole and 27 gram per mole respectively. So you have to calculate how much quantity of electricity in terms of Faraday required. So it is very simple if you write the correct reaction. So remember that calcium is always Ca2 plus, because Cl is 1 minus, there are 2 chlorine, so 1 Ca carrying 2 plus charge. Oxygen is 2 minus, so 3 oxygen carrying 6 minus, divided by 2 means Al carrying 3 plus. You must know the correct charges of that metal cation. So Ca is 2 plus, so definitely when it get deposit, Ca2 plus 2 electron gives Ca, and Al is 3 plus 3 electron gives Al. So these are the reactions. Okay. So 1 mole of aluminium, 1 mole of calcium, that is molar mass is 40 gram per mole, requires 2 mole of electron, that means 2 Faraday. 1 mole electron correspond to 1 Faraday, 2 mole electron correspond to 2 Faraday. So what is the Faraday required for deposition of 20 gram? So 40 gram correspond to 2 Faraday, 20 gram correspond to 20 into 2 divided by 40. Okay, so here is the correction. Instead of 400, it is 40. So 1 Faraday is your answer. Now similarly, for 40 gram of aluminum, you have to calculate. So for Al2O3, Al is 3 plus. So Al3 plus 3 electron gives Al. So to prepare or to produce 1 mole aluminium, 3 mole of electron is required, and 1 mole correspond to 1 Faraday. So 3 mole of electron correspond to 3 Faraday, and which is correspond to 27 gram, because molar mass of aluminum is 27. So 27 gram of aluminum correspond to 3 Faraday, and you have to calculate for 40 gram of aluminum. So 40 gram of aluminum correspond to 40 into 3 divided by 27. So your answer is 4.44. Next numerical is, in an electrolysis of AgNO3 solution, 0.7 gram of silver is deposited. After a certain period of time, calculate quantity of electricity required in Coulomb. Molar mass of silver is 107.9 gram per mole. So this numerical is asked in March 13 for 2 marks. So let us discuss the solution. So what is given? 0.7 gram of Ag is deposited. Then you have to calculate quantity of electricity required in Coulomb. Molecular mass of Ag is given 107.9 gram per mole. So mass of Ag and molar mass is given. So you have to calculate Q. So what is the reaction? Ag is always 1 plus, NO3 is 1 minus. So Ag 1 plus except 1 electron gives Ag. So 1 mole of Ag, which is equal to molar mass, which is equal to 107.9 gram of Ag, correspond to 1 mole electron. Okay, so you have to calculate for 0.7 gram. So 0.7 gram of Ag requires how many mole of electron? Simple cross multiplication, 0.7 into 1 divided by 107.9. So your answer is 6.49 into 10 raised to minus 3 mole. Okay, and 1 mole electron correspond to 1 Faraday. 6.49 into 10 raised to minus 3 mole of electron correspond to how many Faraday? Simple cross multiplication. And 1 mole electron correspond to 96,500 Coulomb charge. So 6.49 into 10 raised to minus 3 mole of electron correspond to simple cross multiplication. So 6.49 into 10 raised to minus 3 into 96,500 divided by 1. So your answer is 626 Coulomb. So this is the charge, but you have to calculate quantity of electricity. So Q is equal to 626 Coulomb. Okay. So you can write this in Faraday and then you can convert that into charge. Okay. Now next numerical is, how much quantity of electricity in Coulomb is required to deposit 1.346 into 10 raised to minus 3 kg of silver in 3.5 minutes from AgNO3 solution. Molecular mass of Ag is 108 into 10 raised to minus 3 kg per mole, and this numerical is asked in July 18 for 2 marks. So mass of silver deposited is 1.346 into 10 raised to minus 3 kg in 3.5 minute, means you are writing second, 3.5 into 60 second, and molar mass of Ag is 108 into 10 raised to minus 3 kg per mole, and you have to calculate quantity of electricity. It is similar to the previous numerical. So again you have to write the reaction. Ag1 plus gain 1 electron to produce 1 mole Ag. Okay. 1 mole of Ag, that means its molar mass is 108 into 10 raised to minus 3 kg, and you have to calculate the number of mole for 1.346 into 10 raised to minus 3. So 1.346 into 10 raised to minus 3 kg into 1 divided by 108 into 10 raised to minus 3 kg. So 1 mole electron correspond to 1 Faraday. So 3.46 into 10 raised to minus 3 kg correspond to how many Faraday? Simple cross multiplication. 1.346 into 10 raised to minus 3 into 1 divided by 108 into 10 raised to minus 3 kg. Your answer is 0.01246 Faraday. So if you have to write in Coulomb, so 1 Faraday corresponds to 96,500. So 0.01246 Faraday correspond to simple cross multiplication. 0.01246 into 96500 divided by 1. So answer is 1202 Coulomb. Okay, that is the amount of electricity required. Then next numerical is calculate the current strength and number of moles of electron required to produce 2.369 into 10 raised to minus 3 kg of copper from copper sulfate solution in 1 hour. Molar mass of copper is given and it is equal to 63.5 gram per mole. Okay, and this numerical is asked in December 18 or 3 months. Now mass of that copper deposited is 2.369 into 10 raised to minus 3 kg and molar mass is 63.5 gram per mole. So for compound is CSO4, SO4 is 2 minus, so Cu is 2 plus. What is the reaction? Cu2 plus 2 electron gives Cu. Okay, time is 1 hour, means 1 into 60 into 60, that is 3600 second. Okay, so Cu2 plus 2 electron gives Cu. So to produce 1 mole of Cu, 2 mole electron required. That means 2 Faraday. And what is the 1 mole of copper? It's equal to molar mass 63.5 gram per mole. That is in kilogram, 63.5 into 10 raised to minus 3 kilogram. So 1 Faraday means 96,500 into 2 means that much Coulomb. So 63.5 into 10 raised to minus 3 kg copper require how much quantity of electricity? 2 into 96,500. But the copper deposited is 2.369 into 10 raised to minus 3. So simple cross multiplication into 2 into 96500 divided by 63.5. So if you solve this with logarithm, your answer is 7200 Coulomb. That is Q. But you have to calculate current, and time is 3600. So I is equal to Q divided by T. So 7200 divided by 3600. So your answer is 2 ampere. 96,500 Coulomb correspond to 1 mole electron. 7200 Coulomb correspond to how much mole electron? 7200 divided by 96,500. So your answer is 0.07461 mole electron. Okay, these are the two answers. Now next numerical is in this numerical some part is missing. I will read that. You have to write the electrode reaction and net cell reaction for fuel cell, and you have to calculate EMF of the cell, which is a Daniell cell, but molarity is different, at 25 degree centigrade. Zinc solid in presence of Zn2 plus, molarity 0.1 molar, which is in contact with Cu2 plus 0.5 molar in presence of Cu solid. The standard reduction potential, that is SRP value of zinc and copper, are minus 0.76 volt and 0.334 volt respectively. Okay. What is the given thing? SRP values are given. For zinc electrode is minus 0.76 volt and that of copper is 0.334 volt. Concentration of Zn2 plus is 0.1 molar and that of Cu2 plus is 0.5 molar. You have to calculate EMF of the cell at 25 degrees centigrade. So what is the reaction? It is the Daniell cell reaction. Zn solid plus Cu2 plus aqueous gave Zn2 plus aqueous plus Cu solid. So if you remember the lone paint word, then you can easily write left hand side is anode where oxidation takes place, which is negatively charged electrode. So E0 cell is nothing but cathode reduction potential minus anode reduction potential. So E0 copper electrode minus E0 zinc electrode. So 0.334 minus 0.76, that is 1.094 volt. But you have to calculate EMF of the cell. E0 cell is standard reduction potential of that cell, but there is some correction which is given in this part, second part, and it is subtracted from standard reduction potential of that cell. So E0 cell minus 0.0592 divided by n log of concentration of Zn2 plus into concentration of Cu solid is 1 divided by concentration of Cu2 plus into concentration of Zn, which is 1. So they are not written here because they are in solid state. So substituting the values of E0 cell is 1.094 minus 0.0592. What is n? N is how many number of electrons are transferred. That reactions are not given here, but you write the reaction. Anodic oxidation is Zn gives Zn2 plus 2 electron, and the 2 electrons gained by Cu2 plus. So Cu2 plus 2 electron gives Cu, and if you combine these two reactions, then we get the overall reaction. So how many number of electrons are transferred? That is 2. It is written as n into log of concentration of Zn2 plus is 0.1, that of copper 2 plus is 0.5. Okay, so actually this numerical is for 4 marks. Here wrongly written as 2 marks. So your answer is 1.1146 volt. Okay, so you have to solve this first. Logarithm of 0.1 divided by 0.5 means log of 1 by 5. So if we multiply this by negative sign, then this term get reverse. So it becomes plus, and this answer is 0.0296 into log of 0.5 divided by 0.1. So that is nothing but log 5, and log 5 that you know. What is the log 5? It is 0.6990 into 0.0296. Okay, and that answer is 0.0207. Subtract that from 1.094, your answer is 1.1146 volt. That is the EMF of cell. The next numerical is calculate E cell and delta G for following at 28 degrees centigrade. Reaction given: Mg solid plus Sn2 plus molarity 0.04 gives Mg2 plus molarity 0.06 molar plus Sn solid. Standard reduction potential of the cell is 2.23 volt, and you have to write is the reaction is spontaneous. So first you have to calculate EMF of the cell, then you can calculate delta G, and then you can write whether the reaction is spontaneous or not. So with the help of this overall cell reaction, you can write two reactions. So two changes are Mg gives Mg2 plus 2 electrons. So it is oxidation takes place at anode, and Sn2 plus gain that 2 electron gives Sn. This is reduction at cathode. So overall transfer of electron is 2, that is N. So E cell is equal to Formula is E0 cell minus 0.0592 divided by N, which is equal to 2, into log of concentration of Mg2 plus, which is 0.06, into concentration of Sn, it is solid in state, so write down as 1, divided by concentration of Sn2 plus is 0.04, into concentration of Mg is 1. So, and E0 cell is 2.23 volt. So if you substitute these values, then 2.23 minus 0.0296 into log 10 log of 1.5 to the base 10. So if you solve this, log of 1.5 0.1761 multiplied by 0.0296, your answer is 0.005213. Subtract this from 2.23, your answer is 2.224 volt. Okay, so remember, if your EMF of the cell is positive, it always equals to positive, then and then your answer is correct. This is the confirmation whether you go wrong or whether your track is correct. Okay, now you have to calculate delta G. What is the formula of delta G? Delta G is minus NFE of that cell. So minus 2 into 96,500. EMF of the cell is 2.224. So your answer is minus 4.292 into 10 raised to 5. How it comes to joule? Your Faraday is nothing but 96,500 Coulomb. EMF is 2.224 volt. So Coulomb volt or volt Coulomb is nothing but joule. And if we divide it by 10 raised to 3, that means 1000, then your answer in kilojoule. So minus 429.2 kilojoule. Okay, so logarithm is given in this way. In this way you have to write the log to one side of your answer sheet. Since, remember this hint, your delta G is negative, therefore electrochemical cell is spontaneous. You write this as your answer. If delta G is positive, your electrochemical cell is non-spontaneous. The next numerical is, write the cell representation and calculate the equilibrium constant for the following redox reaction. This numerical is asked for 3 marks in July 17. So see the overall reaction. Nickel solid plus 2 Ag1 plus aqueous 1 molar gives Ni2 plus aqueous 1 molar plus 2 Ag solid at 25 degrees centigrade. E0 nickel is equal to minus 0.25 volt and E0 Ag is 0.799 volt. Now from this overall reaction you can write the cell representation. For that purpose you must familiar with the anode and cathode. How to identify this? Remember the word lone, L-O-A-N. L for left, O for oxidation, A for anode, N for negative. So first write down two changes and identify which one is anode. For that purpose you must know the oxidation reaction. So Ni gives Ni2 plus. When it gives 2 plus, then it loses 2 electrons. So loss of 2 electron is nothing but oxidation, and it takes place at anode. Anodic oxidation is the word. So Ni gives Ni2 plus 2 electron. This is oxidation, and nickel is the anode. Okay, Ag is 1 plus. So Ag1 plus accept 1 electron gives Ag. 2 Ag1 plus accept 2 electron gives 2 Ag. So here gain of electron, reduction reaction, and reduction takes place at cathode. So your Ag is the cathode. Okay, and how will you write the cell representation? So anode is on left hand side and cathode is on right hand side. So your cell representation is Ni solid, single vertical line, Ni2 plus aqueous 1 molar, double vertical line, Ag1 plus aqueous 1 molar, single vertical line, Ag solid. Okay, so this is your cell representation. Now SRP value of that nickel and Ag is given. Now E0 cell is nothing but E0 of cathode minus E0 of anode. So E0 of Ag electrode minus E0 of nickel electrode. So 0.799 minus 0.25. So your answer is 1.049 volt. Remember this, E0 of the cell is always positive. Then and then your solution is correct, because that cell can produce electricity and reaction is spontaneous. Okay, so if your this E0 cell is negative, then there is a wrong solution. So check the your cathode anode and find out the correct answer. Then E0 cell is nothing but 0.0592 divided by n into log of k. K is equilibrium constant that you have to calculate. So rearrange this formula. Log of k to the base 10 is nothing but n into E0 cell divided by 0.0592. So substitute the values. N is equal to 2 because 2 electrons are transferred. E0 cell is 1.049 and divided by 0.0592. So your answer is 35.44. Okay, that is log of k. Taking the antilog of both sides, log and antilog get cancel in left hand side, so k is remain, and on right hand side you have to take antilog of 35.44. So your answer is 2.754 into 10 raised to 35. Okay, it is the equilibrium constant. Then next is calculate the EMF of the cell having following cell reaction at 298 Kelvin. So reaction is 2Cr solid plus 3Fe2 plus aqueous gives 2Cr3 plus aqueous plus 3Fe solid. Numerical is asked in January 19. Okay, E0 of cell is 0.30 volt. So E cell is nothing but E0 cell minus 0.0592 divided by n into log of concentration of Cr3 plus raised to 2, because 2 moles of Cr will be produced, so power is 2, into concentration of Fe solid raised to 3, but concentration of Fe is 1 because it is in solid state, divided by concentration of Fe2 plus, how many moles will be produced? 3, so raised to power 3, into concentration of Cr solid raised to 2, but concentration of Cr is 1 because it is in solid state. So don't write that here because they are in solid state. So how many number of electrons are transferred, that you have to identify first. Cr gives Cr3 plus. 3 plus means it loses 3 electrons. Okay, and 2 into Cr means 2 into 3 electrons, so 6 electrons. That will give 2Cr3 plus. So your reaction is 2Cr gives 2Cr3 plus 6 electron. Fe2 plus gain 2 electron to gives Fe. 3 Fe2 plus gain 6 electron gives 3 Fe. So how many electrons are transferred? It is 6. Okay, so n is equal to 6. E0 cell is 0.30. Substitute these values in this formula. What we get? 0.30 minus 0.0592 divided by 6 log of concentration of Cr3 plus is 5 into 10 raised to minus 3 raised to 2 divided by concentration of Fe2 plus is 5 into 10 raised to minus 2 raised to 3. So if you solve this, 0.30 minus 0.0592 divided by 6, and this is nothing but 5 square divided by 5 cube means 1 by 5. So solve that, your answer is minus 2.6990. So your final answer is 0.32663 volt. So that is the answer. Thank you for watching my video. My YouTube channel is KHARGE. If you like this video, you can subscribe and share. Thank you very much.